Okay guys, what we're going to do here is we're going to look at the cosine curve. We looked at the sine curve, and remember, the sine curve simply was a periodic function where we looked at the values, the y values of the unit circle, different points on the unit circle. Now what we're going to do here is we're going to look at, essentially, remember cosine is x values, and so what we're going to do is we're going to look at the same x grid. Really going to break it up into fours. So along our x-axis we'll start at 0, and most of the time what we'll do is we'll go pi over 4, pi over 2, 3 pi over 3 pi over 4, and then pi. And then after that we'll continue on from there. But what we're going to do is now we're going to plot the x values of all those coordinates along the unit circle. And so that's what that says there. The cosine function essentially matches the measure of an angle in standard position with the x coordinates of a point on the unit circle. So this point is where the terminal side of the angle intersects the unit circle. But we're talking about matching the x coordinates on our unit circle. So if you recall with the unit circle, um, you start on the standard position side, you have 0.10, and then when you go pi over 6, the x coordinate there is root 3 over 2, and then at pi over 3, the x coordinate is 1/2, and then when you get to pi over 2, the x coordinate is actually 0. Okay, and so what we'll do is we'll list all those values, kind of like we did with the sine curve here, and then we'll look at where the interval increases, where we're decreasing, and then we'll draw a sketch of the curve here. So the period of the cosine function, just like with sine, is going to be 2 pi. So the period of that function is going to be 2 pi. That's before any transformations, any horizontal dilations that might occur. We're going to graph the interval of cosine over from 0 to 2 pi. So again, if you think about when x equals 0, the cosine value, that's 1. If you think about the unit circle, then when you go to pi over 6, the x value there is root 3 over 2. Jump up to pi over 3, then the x coordinate becomes 1/2. And then at pi over 2, which is at the top of the unit circle, our x coordinate is 0. Okay, x coordinate 0. And then when you jump into quadrant 2, remember that's where x becomes negative. So 2 pi over 3, that's negative 1/2. 5 pi over 6 is negative root 3 over 2. And then pi is, the x coordinate is negative 1. And so what happens is this also has a range of negative 1 to 1, just like the sine function did. And so when you think back to the unit circle, 7 pi over 6 has an x coordinate of negative root 3 over 2. And then 4 pi over 3 has an x coordinate of negative 1/2. And then down at the bottom of the unit circle, 3 pi over 2, that x coordinate is 0. And then as we jump into quadrant 4, 5 pi over 3 has an x coordinate of 1/2. It's positive again. And then 11 pi over 6 is root 3 over 2. And then 2 pi, again, you're back at the starting point, so the x coordinate is 1 there. Okay, and so I'm going to point out a few important points that we'll use to graph here later. But real quick, a few important points here is we've got this point here that I'm highlighting in green. Okay, that's going to be one of our max points. Okay, then right here at pi over 2, where we jump from positive to negative, that's an intercept or an inflection point. And then at pi, that's our minimum. And then at 3 pi over 2, another inflection point or intercept along that x-axis. And then right here we're back to the max. So it's a periodic function. It's going to repeat on a cycle, okay, and it's going to start at 2 pi. We'll show some examples where it does change, that period does change, but for now it's going to be 2 pi. So the intervals where the y values in this case for this function are increasing, if you look, they start at pi because all along from 0 to pi those values that we have in red are decreasing. So that where it's increasing are from pi all the way to 2 pi. Okay, that's where the values are decreasing, and then at 2 pi or 0, those values start to decrease again. So where are they decreasing? They're decreasing from 0 all the way to pi. Okay, and that goes back to the unit circle. So I mean, just a quick sketch here. If you do have a rough sketch of the unit circle here, and we have our circle going around just like this, you know, from here, I'm highlighting in green and starting from here all the way there, our x values are decreasing. It's because we're going to the left. Okay, so all of that would be where cosine decreases, that in green. And then from there, if I highlight something, let's say red, from red all the way up to here, okay, our cosine values are increasing. So you got to remember when you're talking about cosine, you're talking about the x values there. And so think about moving along left to right on a x coordinate plane. And so again, the maximum points and minimum points, we've already pointed those out. We have two maximum points here. So our max would simply be at 0, 1, where we start, and where we finish, which is 2 pi, and it has the same coordinate, which is 1. The minimum, which is -1, would be at pi, -1. Okay, so let's take a look at what that curve looks like here. And so if you look, like I said, we use intercepts, maximum points, and minimum points, just like we did with the sine curve. We use our 5 key points here. Intercepts, the maximum points, and the minimum points to graph our curve. And if you look, here's a very basic example of our cosine curve. Okay, and I want you to notice that the cosine curve begins up here at 0, 1. Alright, that's the difference between cosine and sine. Cosine's going to begin here at 0, 1. We have an intercept of pi over 2, that's where it was 0, and then our minimum occurred at pi, just like this. And then back up to 3 pi over 2 was another intercept, and then 2 pi was our max again. Okay, so make sure too you have some concavity when you draw these curves. Some of y'all like to draw lines when we're talking about periodic functions. Some of you like to draw lines like this, straight. Make sure there's some concavity in the lines here. Okay, so don't just draw straight lines, but we're talking about curves. So let's take a look here at some key properties of the cosine function to remember. It does continue to repeat over and over again, so that's -pi to pi is your domain. The amplitude is going to be the absolute value of a, and what I mean by a is is there a number in front of the cosine function. And so if this is your cosine function, let's say y equals 3 cosine of 2x, the 3 here is considered a, and so our amplitude would be 3 there. Okay, the range, just like with the sine function, is going to run from -1 to 1 before any multiplying, some vertical dilations might exist. But a standard cosine curve is going to range from -1 to 1. And then the period is going to be, again, 2 pi over b. And I'm gonna talk about that in some of our examples, how to find the period of that function given what's given to us in the equation itself. But we've already mentioned some key points. We got to have the max, we got to have an intercept, we got to have the min, we got to have the max or another intercept, excuse me, and then finally the max again. Okay, so those are our 5 key points that we're going to use. So let's look at this example here. We're going to use our 5 key points to the parent function, and our graph is going to be 1.5 cosine of x. And so that's what I was talking about here. The 1.5, the 1.5 here is going to be our amplitude. And so what that means is that our function actually will go from 1.5 to -1.5. So if you talk about what transformation just happened here, this is really a vertical dilation. This really is a vertical dilation of 1.5. So remember, vertical dilations affect the y coordinate. So if we're talking about what happens to the x and the y coordinate, what happens is that the x is going to stay the same. Nothing affects the x coordinate. But the y values are going to get multiplied by 1.5. Okay, because we have a vertical dilation of 1.5 here. So if I write out, if I have the point 0, 1, 0 is going to stay the same, but now the y value is going to be 1.5. Okay, pi over 2 stays the same. 0 times 1.5 is still 0. And then pi over pi stays the same. -1 times 1.5 is -1.5. 3 pi over 2 stays the same. Again, the x values are not affected at all. But then 0 times 1.5 is 0. And then 2 pi stays the same. The x coordinates don't change. 1 times 1.5 is 1.5. Okay, so we'll plot those points. Notice right here again that your x axis, when you're graphing these functions, just want to point out your attention, okay, that we are working in terms of radians. So it's pi over 2, then pi. So that makes this, just so you're aware, that makes this little line pi over 4. That makes this line 3 pi over 4. And that makes this, okay, 4 pi over 3. Or I'm sorry, 5 pi over 4. Back that up. That would be 5 pi over 4. Okay, so the x-axis there is in terms of radians. So let's plot our points we have from our graph, and you can see what this cosine curve looks like. So we said, if we look at our points here, we are at 0 and 1.5, so that's here. Pi over 2 and 0 is here. Pi and -1.5 is here. 3 pi over 2 and 0 is here. 2 pi and 1.5 is here. And so make sure again that you have some concavity in your curves. And there is one cycle of our 1.5 cosine of x. Okay, so let's look at another one. So we want to use the 5 key points to graph the function -2 cosine 1/2 x. So here's what we got. Let's talk about the transformations that occurred here first. The negative out front means that we reflect over the x-axis. That's the negative out front. The 2 is a vertical dilation by a factor of 2. And then the 1/2 x being multiplied on the inside is a horizontal dilation That's a horizontal dilation. And remember, horizontal is the reciprocal, so that's by a factor of 2 as well. Okay, horizontal dilation by a factor of 2. And so, if you think about this, the horizontal dilation will affect all the x coordinates, so that's 2 times x. And then the vertical dilation and the reflection will affect the y coordinates. Okay, so here's what we got. If we start again with 0, 1, and notice we're starting with the same 5 points every time. Now what's going to happen is 2 times 0 is going to be 0. Negative 2 times 1 is negative 2. So what's going to happen is, instead of starting up here and above the x-axis, we're actually going to start down here at 0, negative 2. Now, if I multiply pi over 2 times 2, that's going to give me pi. And then if I multiply 0 times negative 2, that's going to be 0. So now what happens is the intercept stretches out and it occurs at pi here, where I'm drawing this blue dot. Go back to your points. If I do 2 times pi, I get 2 pi. And if I do negative 2 times negative 1, I get positive 2. So now at 2 pi, I'm up here at 2. And then from there, if I do 3 pi over 2 times 2, I get 3 pi. And then if I do 0 times negative 2, I get 0. And so what happens is now we are back to 0 at 3 pi. And then finally 2 pi times 2 is actually 4 pi. And then 1 times negative 2 is back to negative 2. So at 4 pi we're back to negative 2. And then again draw some concavity here. And we have our cosine curve. Just like that. Okay, so again we reflected over the x-axis, so now you see instead of starting at 0, in this case 0, negative 2, because we also have a vertical dilation by a factor of 2, and then the horizontal dilation by a factor of 2 there, and there's our points and there's our curve. So now if we look at this one, the last example, we have 3 times the cosine of x minus 2. So if we talk about the transformations that occurred here, the 3 out front, our amplitude, has now become a vertical dilation by a factor of 3. And then the minus 2 means that's a vertical transformation or translation down because of the negative by 2. Vertical translation down by 2. So what happens is both of these are going to affect the y coordinate. Okay, so we're going to essentially do 3 times y and then minus 2 to get our new points. So if you want to go ahead, the x coordinates are going to stay the same. Nothing changes horizontally. Okay, so all these are staying the same. The only y coordinates get affected. Okay, and to point that out, I'm going to do a different color. So 1 times 3 is 3, minus 2 is actually 1. So that doesn't change at all. But then 0 times 3 is 0, minus 2 is negative 2. Negative 1 times 3 is negative 3, minus 2 is negative 5. 0 times 3 is 0, minus 2 is negative 2. And then 1 times 3 is 3, minus 2 is still 1. Okay, so let's plot these points and point out a few key features here. We're going to start at 0, 1. Pi over 2 is now negative 2. And then pi is down here at negative 5. Alright, and then back up to negative 2. And then back up to 1. Alright, so we have our curve with some concavity here. Okay, now I want to point out the fact of, because our graph moved down 2 units, we now have a different midline here. And so if you look, we have an amplitude of 3, which means our midline is going to be here at where I'm drawing it in green. We've got a midline here at y equals negative 2. Y equals negative 2 is our midline there, and so that's what happens there. And then our amplitude is going to be 3. Okay, and just remember, amplitude is the distance between our max and our midline. Okay, so 1, 2, 3, that's our amplitude, this little distance here. That would be our amplitude. Amplitude is equal to 3, which again is equal to the number out in front of the function itself. I'm going to record another video working out some examples of each one, sine and cosine, for you to go back and watch as well.